Hi, I'm Michael Hastreiter, and today I'm going to talk to you about the video portion of my project, the machine learning on card types chosen to predict the winner of a board game. We're looking at the board game Seven Wonders Duel. Within Seven Wonders Duel, there are different card types, red cards and green cards, that help provide a different path to victory, getting shields or symbols. Now, Battlespace Next is a game to teach young officers about joint all-domain warfare, and it has different card types too. It provides that education, but in order to give that education, it needs some engagement, some game balance to provide that engagement. You don't want to have one card type, like the air cards, being way more powerful than the cyber cards. So in Seven Wonders Duel, you have different ways to win, and every turn you're going to be taking one of these cards to help with those wins. There's also different expansions that can enhance those wins, Pantheon and Agora, as you see here. We talked about the ways to win with military and the ways to win with science, but there are other ways. My objective was to create a prediction model using only card type related features, trying to tease out which card would be an overpowered card type. Evidence for an overpowered card type would be if I created a really high accurate model, and if that model was a logistic regression, I could take the coefficients of that regression and kind of show that one coefficient was very high for a feature, meaning that that feature was overpowered. It would just be evidence to such. I figured that yellow cards would be a high predictor, and then I knew that from my games on Board Game Arena. I took 2021 games, I had 10,000 matches that shown from top players, and then in 2023, there were 7,000 matches from top players. So I used the golden rule where I wouldn't mess with the test data until the very end. I would do a comparison of my model. But the non-test created my model. It was a categorization supervised learning problem. I had 82 features, reduced it down to 38 because some of those features were just way too powerful. Similar to having a 4 in a row and Connect 4 and saying that's a win. I didn't want to have something like that. I would rather something more like a material advantage in chess or something like that to predict a win. So those different card type choices would provide the accuracy that I needed. I ended up doing an L1 penalty to take down all those 38 features down to 4. And here are the remaining 4 that seem to be the most powerful. But I still wanted to create that model. So here are the 3 ways to win. Actually, 4 ways if you count the Agora expansion. And this is all the 10,000 matches. The big graph is all 10,000, and then the smaller subset of graphs, you see the different split of expansion situations. You'll notice that with only the Pantheon expansion, the green was very high. I had different methodologies for feature selection. The traditional ones being forward and backward selection. Forward, I explicitly stopped at 10 features. The backward, I predicted using k-fold cross-validation of n splits equals 5 and shuffle equals true. And as soon as got an accuracy of less than 70%, I stopped taking away features. And then I also did a ridge and a lasso regression, and whenever win equaled greater than 0.5, I would say that was considered a win, and less than 0.5, that was considered a loss. And then I used that to predict accuracy there. And you can see the spit out of the different accuracies of the ways that I tried to narrow down the features. With ridge, I ended up just taking the top 10 features, and I used a logarithmic sweep of different alphas. I also plan to use different model fitting techniques. So mostly discussed all this. There were balanced classes, hyperparameters I looked at. Also, I'm going to look at threshold here in a bit, and you'll see confusion matrices as well. And right here is a rock curve. Forward feature selection was what I ended up using for all of my non-test data altogether. And it actually had very similar coefficients to the and features to the lasso model. Now, I tried to fit an LDA and QDA models, and those had no significant differences in accuracy. I also changed the thresholds a bit, but that really didn't help the accuracy. Here's a confusion matrix for when 0.49 was a little bit better. Then finally went to testing the model. Forward feature selection was what I chose, but you can see that lasso was very similar, and that you can see the logistic regression equation there showing that white cards and red cards and green cards were very powerful. And the accuracy I had on the non-test was 73%, and the test was around 71%. So not too bad of a drop, showing myself that, hey, maybe in the future, 2024, 2025 data comes out, I can still use this model with similar accuracies. I also did fit as decision tree. I don't want to talk too much about this, but it just shows a visualization of, hey, green is important, white's important, and red's important. And I ended up getting an accuracy of close to that 70% with a max depth of 12, but it was fairly difficult. I ran the whole process again with different versions of the game, and those are my predictions below. And that's the actual of what actually happened. What were the best ones? So, in conclusion, no single card type was proven to be overpowered. It was just useful evidence. However, in the Pantheon expansion, the green was significantly more powerful than the others, and that's actually very similar to what experts do feel about the game. In conclusion, I think a deep dive could be done on individual players, and that could have usefulness in studying top military leaders and their styles of real life and how they're trying to win wars rather than just a game. And then DoD serious games, you can always break down the decisions into color groupings like I did here and try to figure out a win based on those. And there's a lot of work that can be done there. Any questions, please email me. Thank you so much for watching, and take care.